Hello dear students, in the sequence of numerical method, this is the first lecture of finite differences. So what is finite differences? First of all, let the function y equal to fx. Suppose this equation is equation number 1. Here x is known as the argument. Here x is, when we take y equal to fx be any function, here the value of x is known as argument and the value of x can be taken equidistant and y is known as entry. Now suppose we take the number line. Suppose x be a center point. On the right hand side we consider a point on the top of x is a, and here is equidistant value from x to first position. Here is the difference of this part is h, so it becomes, the second point becomes a plus h because the point are equidistant. So again the distance between this and this point is h, so the next point is a plus 2h. Similarly on the left hand side is a minus h and a minus 2h. Therefore the value of y equal to fx corresponding to the above values of x are: the first point on the top of x is a, so here be the function form f of a, and the second point is a plus h, f of a plus h, and the third is f of 2 plus f of a plus 2h. Similarly dot dot dot, and the last one is f of a plus nh. Similarly we can take the same result in the form of function with respect to the left point a minus h, a minus 2h. Now see, there are two types of finite differences. There are two types. First is forward finite difference, and it is denoted by this triangle form. And the second is backward finite difference, and it's denoted by like this. Therefore the following differences are called finite differences: f of a plus h minus f of a. Initial point is of the function is fa, next point is f of a plus h. When we subtract next point to the initial point, f of a plus h minus f of a, it becomes the del of fa, means finite difference of fa. Next is f of a plus 2h minus f of a plus h, then it becomes del of a plus h. Third, f of a plus 3h minus f of a plus 2h, then it becomes del of f of a plus 2h, dot dot dot, and the nth part is f of a plus nh minus second last point f of a plus n minus 1 of h, here is s is missing, equal to a of equal to this triangle of f of a plus n h. In general, the first difference of fx is defined as del of fx equal to f of x plus h minus fx. So this is the formula of forward difference formula: del of fx equal to f of x plus h minus fx. That this is operator. This notation is known as operator and is called forward difference operator, or simply a difference operator. And h is here h is known as the interval of differencing. Similarly, if the difference is like this, f of x plus h minus fx, and then it is called the backward difference. This is the notation of backward. difference operator. Note that if you have the notation like this, it means that it can be del of del x. Suppose this is the backward operator. Suppose this is the forward operator. This is del of del. Now take the example. Del of tan inverse x equal to, evaluate this triangle of tan inverse x. So by the formula, del of fx equal to f of x plus h minus fx. So consider the given function be fx equal to tan inverse x. Replace x by x plus h, so it becomes tan inverse x plus h. Here is the forward difference formula, f of x plus h minus fx. So put the value of f of x plus h here, then minus as it is tan inverse x, the value of fx. So this is the value of f of x plus h, tan inverse x plus h, and this is the value of fx, tan inverse x. Now using the formula of tan inverse x minus tan inverse y, what is the result? Tan inverse x minus y divided by 1 plus xy. So this is x form, tan inverse as it is. This is x of x plus h minus, this is the place of y, 1 plus x into this part. By using the formula tan inverse A minus tan inverse B, x should be cancelled. So it becomes, the final result is tan inverse h of 1 plus x squared xh. So this is the all idea about the finite differences. In the next video, we will discuss the forward and backward difference result in terms of Newton's forward method and Newton backward method. Thank you.